All right, kids, so what we have here is this desk is going to represent the mantle of the Earth. And we'll learn about, there are certain spots in the mantle, scientists aren't exactly sure why, that are hotter than others. They call them hot spots. So we're going to use this candle as an example of a hot spot. And I'll just draw a circle around that so you know where that is located. We'll draw some directions on the desk here, so that we can talk about cardinal directions. We've got north, south, east, and west. Now, this sheet of paper is going to represent a tectonic or lithospheric plate. We will have a position where we start, okay? And that will be where the hot spot is going to start over. And we are going to move that plate over the hot spots, because as we've learned about in plate tectonics and continental drift, plates do move. So what we'll see is that hot spot will sit in a spot for a while, and it'll move along, and it will leave a little mark. In the case of the real world, those would be volcanoes that burn through, right? And as time goes on, okay, we end up with a chain of marks or volcanoes that give us an idea of how the plate has moved. So first things, has the hot spot moved at all? You can look on the desk and decide for yourself. So I'm going to blow it out just because I don't want to get burned here. Okay. So if we rewind and put the start, okay, over here, and I look at the cardinal directions on the desk, and I kind of play this like a movie from the start to the end. Now look at the direction the plate, the piece of paper, is moving. You can start to determine the direction that's moving. So in this case, this plate moved towards the southeast as time went on. As I go from where we started, the oldest volcano or island, to the current one, all right? And that's how we use hotspot volcanoes to determine the motion and direction of motion and speed of motion of tectonic or lithospheric plates.